All right, so this is now chapter 24 is what we're going to look at. And so chapter 24 is looking at process planning, which I said we're going to do this pretty quickly because we're going to look much more in depth at process planning next week when we look at chapter 25. So overall process planning, we're looking at the sequence to make a part or to assemble a part or to package a part. And we have to look at the equipment and the capacity of our equipment. Um, and anything that we can't make, we need to outsource from vendors. So whether it's raw material that's coming in that we're then converting in some process, or it's outsourcing an actual subcomponent that someone else makes and delivers to us, that all has to be part of the sequencing and planning. So the first things are looking at those drawings, those CAD drawings, and knowing what dimensions, tolerances, materials we need, and what equipment is used to get to that end stage. And so again, this is part of the make or buy decision. If you have the equipment um, for that part, that's great. If you don't, you either have to get the equipment, which is very expensive, or you have to outsource. The tools, dies, molds, fixture, gauges are all the specialty tooling associated with that specific product. Then you have to look at the methods itself, like how does the material get there, who's loading the machines, how long is the machine cycle, who unloads it, what sort of tooling do you need, and what sort of conditions are required. And so starting with a basic raw material, you'll then do an initial process, usually like a cutting process, and then you have additional processes depending on what the finished part is going to look like. So here are some examples. If you're doing a sand casting, usually there's also machining and heat treating and like painting as a finishing. If you're rolling sheets out, then you have a blanking and bending stage. Plating it might be a part of it. When you're forging a material, then there's machining that's done afterwards and possibly painting. Extruding, you typically cut to length and then anodizing it might be a process. And casting of glass, there's pressing, blowing, and then you anneal it and etch it as required. So for example, you might have someone who does the rolling and blanking and plates the raw material, and then those blanks become the raw material that you then do addition, milling, lathing, drilling, etc. So you can see there's multiple process sequences that could be included. And so process routing sheets are used to determine what type of equipment is required, what tooling is required, how long it's going to take to get from a raw material or the incoming material to your final part. And this is an example of one of those routing sheets. In assembly, you would also be looking at all of the sub-steps to have an assembled good, all of the fasteners, all of the individual parts, whether it's automated, semi-automated, all manual labor. That layout of the equipment and then the flow of the product through the process for that final assembly is part of process planning. And then finally, I already mentioned make or buy. Whether you're starting with a raw material or you're starting with a vendor component, your process planning looks pretty much the same. Some companies will outsource many of the subcomponents. Very few companies actually take it from raw material all the way to finished good without any other external suppliers. And so this question of making or buy usually comes down not just to the individual unit cost, but also labor capabilities. Is it a specialty piece of equipment that is a large high capital cost that you don't want to assume? Is it a specific technique that only certain specialists know how to do and your personnel don't know how to do that? So there's a lot of factors that could go into deciding whether or not you would make a product or buy the product. And it's not just about dollars and cents of the individual unit, but the loaded cost, including the personnel, the equipment depreciation, the time that it takes to process, how that fits in with the rest of your production process flow, and all of those things would be considered. So when we look at product development, as we talked about in chapter 23, we said that oftentimes you develop this product into a CAD or CAM system that can then be manufactured. Well, if that process was done kind of the traditional way, there would be this product design based on the customer need, and then it's kind of handed to manufacturing and process planning to figure out how to actually produce the part and assemble it. When you look at concurrent engineering, you actually have input from the manufacturing floor and from the people who do production and assembly to give feedback, which can help save time and money because they might have suggestions on how to implement it more quickly. And so you can see in the graph here that the product launch time is often accelerated when you have product development using concurrent engineering, which is why people use that. One concept that's also very popular is design for manufacturing and assembly. And that is basically understanding that the more complicated you make the part and the more complicated you make the process, the more expensive the product becomes. And so if you design the part with the manufacturing process in mind, you can simplify your design to try to ensure a high level of quality and a quick manufacture process. So you might minimize the number of components. You might use common parts across the product line. So like fasteners, you use fasteners that you already use for other products multiple times so that you're not buying a lot of components. Foolproof assembly, so making it so that it can only be constructed one way or the product won't work. Using shapes that are easy to package and easy to manipulate, and trying to reduce tolerances to make sure that they're inside within your process capability so that you don't have quality issues. Other ways to design the product are looking specifically at the highest level of quality, which could involve increased inspection throughout the process. Looking at the cost, which would, in minimizing cost, you might use cheaper raw materials, you might have less features, you might have less detailed work, it might have lower tolerances for acceptability. And then finally, design for life cycle, which actually doesn't look just at the initial product use, but also maintaining it over time. And so like, when you think about a car, it used to be that old cars were made with the idea that a lot of maintenance, like changing your oil, would be done by the purchaser themselves, not going to a service station. Now, if you look at an engine compartment, many of the newer cars, you can barely access components of the engine without having professional equipment like a lift or a slide to get under the vehicle. It's not made for the user to tinker with components. So looking at the design for the life cycle takes into consideration what sort of maintenance is going to be done on it and who would be doing that maintenance. Finally, when we look at advanced manufacturing planning, you're actually trying to take into consideration new product ideas and future capabilities and future technologies. So oftentimes, like 3D printing or additive manufacturing is integrated in small ways first and kind of tested in small batches, in small settings, non-critical components, things that aren't really high volume, to figure out if it's a good match for your company before you invest heavily and do things more at a large scale. Same thing for like laser cutting or etching. Those types of high tech, when they first come out, are usually adopted slowly, like on an individual line or for an individual product before being adopted widely for the entire facility. But as you're making that consideration, you have to think, well, how will that change our staffing needs? How will that change our factory layout? How will that change our material needs? What would that do to our product mix? And so advanced manufacturing planning is always looking at the newest technologies and the newest capabilities that we can do in a production market and asking how we can integrate them to become more cost effective, more efficient, higher level of quality, and at the end of the day, more profitable. Again, we'll go into details of what this process planning actually looks like from a breakout standpoint when we do our MRP chapter next week. But in the meantime, review your lecture notes, review the chapter, and make sure you check out the homework assignment due Sunday. Stay healthy, stay safe, and as always, contact me if you need anything.